Hello everyone, welcome back. In this video, I'm going to walk you through my project on typo corrections in information retrieval systems using Levenstein distance algorithm. We'll see how simple typo corrections can drastically improve the performance of a searching system, and I will demonstrate that using this Colab notebook. Okay, let's get into the topic. What is information retrieval systems? Information retrieval systems or IR systems is the basically the process of finding the relevant documents from a large collection of documents or a database. Think of it like a Google searching. You type something and it finds matching documents. Most IR models uses TF-IDF and cosine similarity and to rank the results. But here's the catch. If your query has a typo, the system might not find any relevant documents. That's the problem we're trying to solve right now. Okay, let me explain the problem statements again and go through the algorithm. Let's say I want to search for Amazon phone case. Uh, to search for that, I need to type Amazon phone case. Sorry. Let's say if I have searched like this, it will retrieve the documents correctly. Okay. What if I have searched like this? I have missed one letter in each word, but also the suggestions it is showing me like Amazon phone case because it uses the algorithm that we are going to discuss right now. Uh, in the basic IR models, if we don't include this algorithm, it will it may cannot retrieve the correct documents because it don't have that algorithm and it searches for the exact word in the corpus, so we don't get the correct results. So we are going to solve this problem using Levenstein distance algorithm. Okay, let's go into that algorithm. This is the algorithm. Uh, Basically, Levenstein distance algorithm is used to find the similarity between two strings by finding the number of operations required to make one string into another string. Okay, the number of operations allowed are insertion, deletion, and substitution. Okay, insertion means adding a character, deletion means removing a character, substitution means replacing a character. Let's say example, in our case, I have typed Amazon. To make Amazon into Amazon, we required only one operation, that is adding a here. Okay. Uh, in simple terms, the smaller the Levenstein distance, the more similar two words are. It is the intuition we can get. Okay. Now, the pseudocode for the Levenstein, it's very simple. If the we, ha- this is the base case len of s, that means the length of one string is empty, means zero. We need to add all characters that are in T to S to make S into T. Similarly for the T also, if the two characters that we are currently comparing is equal, then the cost is zero, else cost one. We will call the same function recursively to find the minimum number of operations by performing each operation and taking the minimum of all. Okay. This is the algorithm that we can go through in there are various sources in YouTube also. This if I want to explain with an example, it will take more time. Okay, let me demonstrate with an uh, let me demonstrate how these algorithms improves the information retrieval systems using a Colab notebook. Okay, this is the Colab notebook that I have took. First, I am importing all the libraries. These are the sample documents, 20 sample documents that I have taken from the ChatGPT to run the code. And I have created a data frame for it, columns, doc ID, and document text. Okay. Let's say these are the sample means queries of the users. First query Amazon phone case. Second case iPhone charger. It's clearly intended to be iPhone charger, but there is an typo of PHO. Basically, O comes first. So there are typos in these queries, and some are maybe common. Some may not contain the typos. Okay, these are the relevance for the queries. For the first query, these are the relevant documents. To calculate the precision and recall, we are using these documents as the base documents. Okay. For retrieving the documents, we need to consider a model, IR model. So I choose VSM vector space model using TF-IDF and cosine similarity uh, for retrieving the documents. Means I want to retrieve these documents for these queries. Okay. Have run those cells to make our time clear. Okay. This is the algorithm that we will be using to correct the queries. Okay, this is the vocabulary corrected tokens. These are all common. And I want to show the how it improves the performance of the information retrievals, right? So, okay. For this, I'm going through each query and taking its relevant documents. We are retrieving the documents before correction. Means we are retrieving the documents without correcting the query. Means we are using the query as it is and retrieving the documents here. And after correction, uh, we are correcting the query. See, we are using the correct query function which we have wrote in this correct. Sorry, in this correct query, we are using corrected tokens, and it corrected tokens we are using Levenstein algorithm to correct the words and take the top five relevant words to the corrected word. Okay, and storing all the values like precision, recall, and F1 score to further analyze or draw graphs on those. So this is the result we got by running this cell. Original query was Amazon phone case, and the query got corrected to Amazon phone A. You can see in our corpus we didn't remove the stop word, so it considered A as a whole word. But I forgot to remove the stop words. Okay, it's not a problem. Uh, so before precision before means the query actually got precision we got actually for this uh, case, this query, that is 0.6. There is no change here at all. Okay, for this query you can see that iPhone charger, sorry, before correcting the query we got 0.6, but after correct, oh sorry, this is recall before precision after this query is 0.8 for this, and you can see that there is improvements in the performance. So I plot a graph before and after performing the query. This is the graph we get. Blue color is indicating the before correcting. Orange is after correcting. As you can see, the overall precision, recall, and F1 score are uh, uh, increased after correcting the query. Right? Okay. In conclusion, we can say that Levenstein distance is a classic algorithm uh, which is used to correct the typos in the user query and improves the uh, information retrieval systems. That's it. Thank you.